Okay, so for my project, I chose to do questions on social media usage, as I think it's accessible to everyone I think it's accessible to the majority of people in the United States at the moment, but I think it's also especially accessible to people who are on a college campus. So, in order to apply the techniques we learned in this semester, we needed two um, quantitative yielding questions, so two questions that yield numerical or quantitative data, and two questions that yield qualitative data, which will be on the next slide. And then we were just asked, and then one binary, just to see what we could do. Honestly, I didn't use the binary for most for anything. All of the techniques you can use on binary, you can use on qualitative as well, and I found it more enriching. Um, so when dealing with data, there's always the cleaning aspect of um, having to interpret some things that are maybe like, I don't know. Luckily, none of the data I collected needed all that much cleanup. One of the reasons I used multiple choice for the qualitative questions. But this first question, this quantitative question, on average, how many posts, about posting, that one had two major outliers. Then we'll see how that's addressed later on. But this one, this on average, how the hours that you use social media or spend on social media, that one had one question that needed a little cleanup. And it was just, they were like the maximum. And so it's like, okay, well, that's 24. You could have said 24. But next up. Okay. So here we have the qualitative questions. Now, I think it worked out well. I think that the we I yielded we had some good results, but I think in the future I would not use them as multiple choice, even though I didn't have to clean the data, which was very nice. Um, it also meant that I didn't have to that I also think that it might have influenced responses, as they might have maybe thought of something else and they just didn't want to pick other because they didn't want to have to explain, or they just didn't feel comfortable picking others. So in the future, if I asked the same question, I would not use multiple choice and I'd just take the hit and do some more, um, just do some cleanup there. I think the primary use, however, this one might have been helpful specifically because there would be so many answers. Um, you know, so I specified entertainment, income, just in case someone was trying to be an influencer, just to cover my bases, and then communicating with people online, so like your online friends and meeting people online, online groups and stuff, versus communicating with people you already know. So just like checking up on your grandma in Wisconsin or stuff like that. Now, it is important to note that our survey only had 33 responses, so that's a pretty small sample size. We're gonna be affected by outliers, which is why I have to do some extra calculations for for that one quantitative question, because otherwise a lot of stuff is just not not really useful information. All right, let's get into the analysis. So first, let's look at the qualitative question. So most used social media site. As we can see here, TikTok has the majority, and Instagram has about a third. We got one response for X, formerly known as Twitter. Um, that makes sense. I feel like people don't spend a lot of time on Twitter, but TikTok and Instagram are both huge time sucks. So seeing this now, as TikTok has a majority here, I'm wondering if the population at large might have a majority for TikTok as well, might choose TikTok the most. Um, Now, this isn't, like I said, we only had 33 responses, and this survey was not randomly selected. So, this is not a good data set to determine how much to determine anything about the population of Ventura College. But for the purposes of, sorry, for the purposes of learning and using the techniques, we're gonna act like it could be a proper representation of the college. So with that said, I was like, okay, what are the limits? Where can we set a parameter here? So I started with a 90% confidence interval. That's the information right here. And with a 90% confidence interval, with the proportion, this is all proportions because it is qualitative. So we got 21 people responded that they spend the most of their time on TikTok when they're using social media, which gives us this sample proportion of a little bit less than 2/3, and then leaves us this lower limit of 0.498. So a little bit less than 50% of the population is expected here. And then the upper limit is about 77. So the parameter or the confidence interval here is pretty big, but you see it goes from just a little bit under 50 to 77% is expected. So any one of those answers could be could be the true percent if this were representative of the Ventura College population. Now, if you want, 95% is a pretty standard confidence interval. So I also ran a 95% confidence interval, and we can see that the lower limit is 47 here, and the upper limit moved up to 80. So we have expanded. Our parameter is larger here, and that's expected for the more confident you are, the larger your parameter is going to be, because the larger your parameter is, the more likely you have actually got the population statistic in there. But we can see that it actually went a little bit lower for, like I said, because it increased, it went lower than that 49, which was almost 50, and now we could expect as low as 47% of the population to choose TikTok as their main, as their longest time spent. So if we then look, so then I was like, okay, let's run a hypothesis test. See if for the hypothesis test, we use a null hypothesis of the population proportion is 50%. 50% of the population uses TikTok as their main social media. And then our alternative is that more than 50%, the majority of people, use TikTok as their main social media. Now, running that with our test statistics and with our sample, we get a p-value of 0.0586, and I ran this with the threshold being 0.05. So this is above that threshold, which means we fail to reject the null hypothesis. We cannot say that more than the majority, that more than 50% of people will spend most of their social media time on TikTok. We also can't say that 50% do spend their time on TikTok. Just because the null hypothesis wasn't rejected doesn't mean that it is true. We can't test that with a hypothesis test. That's just not how it works. The hypothesis test will tell us basically repeatability. So if this is less than 0.05, so less than 5%, if you want to think of it that way, then it would be really hard for us to get this data again, or even this data at all, for that, if the population was at 50%. is basically how the hypothesis test works. So that doesn't really tell us anything about, if it is at 50%, how likely would we be to get it. Next, so yeah, so we fail to reject the null hypothesis, but that doesn't make the null hypothesis true. It just means we can't accept or give any credit to the alternative hypothesis. Now, I also have the primary use of social media. So we can see most people here, majority of people, again, chose entertainment. And we got 2/3 of our respondents chose entertainment. We got a little bit for just communicating in online spaces, and then the other good portion here, who were communicating with friends or family or people they know in real life. So these are two, I would say, intended uses. I expected these to be a little bit higher, but entertainment is pretty good there. So with the majority being entertainment, I wanted to see, okay, majority was TikTok last time. Let's see if majority entertainment means that the population, again, assuming that this had been a randomly selected study, which it was not, we go. So when we look at a 95% confidence interval for this data, we see that the lower limit is 50. It's technically slightly above 50, but it's about 50%. The population's lower limit, based on our sample data, is 50%, and the upper limit, based on our sample data, is about 82 to 83. So 50 to 51, 82 to 83. Again, that's a pretty big window. That's a pretty big parameter because we have a very small sample size. But it is still usable. So with that being above 50, I ran a hypothesis test with the null hypothesis being p is equal to 0.5. So the proportion is 50. The proportion is 50% of the population uses social media primarily for entertainment. And the alternative being that more than 50% of the population uses social media for entertainment. So that one-way hypothesis test with proportions, and we got a p-value of 0.278, and again I used a 0.05 threshold, and we see that in this case we are under that threshold, so we reject the null hypothesis, and we can say no, based on our data, we believe that it is more than 50%. That's not necessarily, we can't necessarily say, oh, it is definitely more than 50%, but we can say, yeah, it looks like it's more than 50%, based on this very small p-value that basically says if we did this experiment again and the actual population was 50% of the population used the social media for entertainment, it is very unlikely that we would get this result. But again, this is a small sample size and it's not randomly selected, so let's take that with a grain of salt. All right, moving on to okay, so now we move on to quantitative data. So on average, how many hours per day do you spend on social media sites? And we get a pretty big split here. We have a pretty big gap between most of our answers are over here. They're under 15 hours. Highest they go is like 12 hours. And then we have two that are over here in 24 hours. They are spending all of their time on a social media site. So that is quite a gap. Now we do have a small sample size, so that does change things. If we had a larger sample size, we'd probably get more numbers in this big gap. Maybe not as many due to people, sleeping during the day or having work, other things, but we're seeing quite a bit, quite a gap here. With that big gap, we can see that though our median is 4 hours, our mean is a bit higher than that. Our mean is 5.67, so about 5 2/3 of an hour, so a little over 5.5 hours. And we look at our standard deviation, and our standard deviation is 5.2 with a mean of only 5.666 repeating. That's a pretty big wrench in the plan, if you will. And that's really due to these two big outliers over here. Now, if we wanted to get an idea of the parameter, let's do a parameter again. This time, instead of doing a proportion parameter, we'll be doing a mean parameter. And if we wanted to get an idea of what the population, which we're doing Ventura College students, again, just for practice purposes, we get a lower limit of about 3.8 hours and an upper limit of 7.5 hours, which I think is a pretty reasonable parameter. 4 to 7 hours. So with that said, it looks like our median says 4 hours, our lower limit is 8. Now that means anywhere in this 95% confidence interval, which it is a 95% confidence interval, anywhere between these two for the parameter is just as likely as another point. But given our median, I decided to run a hypothesis test with means this time. A hypothesis test on whether or not it was less. The population would spend less than 5 hours a day on social media. And we can see that our null hypothesis here is equal to 5. So the null hypothesis, the mean is 5 hours. The mean of our population would be 5 hours. And our alternative hypothesis is that the mean of our population is less than 5 hours. And when we look at the information we get a p-value of 0.766. That's a high p-value. P-values top out at 1. So 0.05, which is the threshold I used for this hypothesis test, way exceeds that. So we fail to reject the null hypothesis. We cannot say that the population at large has a mean hours per day on social media of less than 5. We can't say that at all. And maybe it would change if we didn't have these 224s. I didn't look at that. I think next time maybe I should look at that. But yeah, we fail to reject. Again, that does not mean, just like in proportions, that doesn't mean that the average is 5. It doesn't mean that the mean is 5 hours a day, but it does mean we can't say it's less than 5 hours a day. Next slide. Okay. So now we're moving on to our final question, which has a lot of work because it was the question that had two big outliers. We had this 420 and 100 posts, which, as you can see from this visual using all of that data, you can't really get anything from this visual. I can tell you that the mean was 18 and the median was 1.5, but you wouldn't really be able to discern that because of how large this y-axis has to be. So when we take out those two big outlying points of data, we see a much nicer visual here of the of the posts made per week on social media. And we can see that we do have 2 outliers still. While most of the data is down here in the 0 to 3-ish range, we still have a few that are up here in the higher and the double digits even. So let's see how this works out now with using all of this data, which again, this is not a usable visual. There's nothing we can discern visually from this. Here we can discern some visuals. We see the median is 1, which we could see, and we see that the mean is about 2.5 with this 5 and the 0 here. So, and that is pretty close to the mean. So this is a good visual, although it does not have all the data, and it is a smaller sample size than our even already pretty small sample size. Next slide. There we go. Okay, so with those 2 big outliers, I decided to run my tests and make my parameters with both all the data and with those 2 outliers removed. So when we look at the parameter we make with all the data, we see an immediate issue in this -8 as a lower limit. You can't make negative posts on social media. That's not something you can do. So we have to interpret this lower limit as a 0. So 0 to 44 for a 95% interval, confidence interval is, I would say 95% that the mean is somewhere between 0 and 44 is pretty reasonable, but it is caused by those 2 big outliers that really kind of mess it up. I mean, when you look at the standard deviation being 74, with most of the answers being somewhere between 0 and 5, that's a pretty decent way to get screwy data. So when we look over here, we take out those 2 outliers and we get a much closer to our sample data limits. We get a 1.28 as our lower limit and a 3.68 as our upper limit. So we are 95% confident that the true population mean is within here, but again, that's if we had a survey that was randomly assigned and of a much larger sample, and especially when we had to remove 2 data points. So we went from 32 degrees of freedom to 30 degrees of freedom. We went from 33 samples to 31 samples, which in such a small size is not good. And we can see that, this data isn't perfect. When we do our hypothesis test, we did a null hypothesis that the average post of the population per week is going to be 1. The average is going to be 1 for both of these. And then we did a 2-way mean hypothesis test for saying that no, it's not. It could be less or more. And when we take this with all the data, the p-value, which again our threshold is going to be 0.05, our p-value is more than that. So we fail to reject the null hypothesis. We can't say for certain whether or not, we can't say basically that our data says that less or more of that the population makes one more or less than 1 post a week. We also can't say that they do make 1 post a week. Like I've said before, just because we fail to reject the null hypothesis does not mean we accept the null hypothesis. It just means no, we can't take the alternative, but that doesn't mean we accept the null. Now, when we take a look over here and we took out the outliers, we actually do reject the null hypothesis. We say no. The population does make one that makes more than one post a week, or they make less than one post a week, but they don't make just one post a week. And I think this is more likely because honestly, I think it's going to be a little bit more than one. I think just based on people who post all the time, and then you have a bunch of people who post like never, you're going to get a little bit more than one. You're probably 3 to 4 based on people who are posting like 50 times a week. But we didn't have any of those data points because we had a very small sample size that just made it smaller by having to remove those big posts that end us with a negative limit that is hard to interpret. And that brings us into the next section. Okay, so now we are in to the point where we are talking about correlation. And this is one of those places where we really needed to be able to remove those 2 outliers because once again, our visual doesn't show us anything. It shows us maybe some linear regression here, maybe some correlation in terms of how much you post and how much time you spend throughout the day. But reality, we can't see most of our data. It is all clustered and we don't know what it says at all. So we removed those 2 outliers and we get a much better view. And we can see here, based on this, there is no correlation between these 2 variables. We have over here, these people all spend 4 hours, but it's across the board in terms of how much they post. Some of them are posting not at all. Some of them are posting quite a bit. And over here, I think my face is covering it. But there is also this one data point of the 24 hours. And that person, again, not a lot of posts there. So with this visual, we're thinking, oh yeah. We're thinking there's no correlation here. But let's prove that mathematically. Okay, so for the correlation, as we saw previously on our scatter plot, this is the scatter plot where we removed the outliers, that 420 posts a week and that 100 posts a week. And we can see there's no correlation here. There's nothing. And that's confirmed by our R-squared value, which is very close to 0. R-squared value is a good measure of how good your line of fit, and that would be this red line right here. Fortunately, my title and axis got kind of cut off in StatCrunch, and I couldn't figure out how to fix it, so bear with me. But this red line, that red line of fit, you can see it. It's almost straight. It almost doesn't have a slope. We can see over here in our equation for the line, that slope is very small. That's a very little negative slope. And our R-square value being so close to 0, when R-square values top out at 1 would be that your data perfectly fits your line of best fit, which is very rare. I've never run across that in the wild. And the closer you get to 0, the less your line of best fit is actually a best fit. And we can see it being so close to 0, this line does not fit at all. There's not a lot here that says correlation. So we can say definitively there is no correlation in the population of Ventura College students based on our data. Our sample data says nope, no correlation. Again, that is a very small sample. Our sample is only 31. There's a lot more people at Ventura College, and it is also not randomly assigned. These are all pretty similar, people. They're all in one math class, so we can't say that. But for the purposes of practice, we can say no. There is not a correlation between these 2. And our R-squared value proves it. Okay? Thank you very much.